There is a building in Denver, Colorado, where workers show up every morning and make money. Literally make it. Stamp it out of metal, count it, bag it, and ship it to banks across the country. And they do it at a speed that is almost impossible to believe. The United States Mint produces approximately 14 billion coins every single year. That is roughly 38 million coins every day. Every hour of every working shift, machines are stamping out over 700 coins per minute, each one perfectly identical to every other one made in that facility for the past century. Now think about what a coin actually is. It is a small disc of metal with a picture pressed into both sides, no electronics, no moving parts, no assembly, just shaped metal. And that shaped metal has been the basis of human commerce for over 2,600 years, from ancient Lydia to the loose change rattling in your pocket right now. But how does raw metal become legal tender? How does a blank disc become a coin that a vending machine can read, a bank can count? The coin is one of the most consequential inventions in human history, and like the paperclip, it emerged without a single named inventor and then immediately conquered the entire world. The first standardized coins were minted in the Kingdom of Lydia in modern-day Turkey around 600 BC. They were made from electrum, a naturally occurring alloy of gold and silver, and stamped with the image of a lion's head, the symbol of the Lydian king. Before coins, trade relied on weighing lumps of metal, grain, cattle, or bartering goods directly. Coins standardized value. You no longer needed scales. You needed only to count. The idea spread with astonishing speed. Within 200 years, every major civilization from Greece to Persia to India was minting coins. The Roman Empire built its financial system and its ability to pay soldiers across 3 continents entirely on coinage. When Rome fell, so did reliable coinage, and the European economy contracted for centuries. The Chinese invented paper money in the 7th century AD, partly because they had run out of copper to make enough coins for their enormous economy. Europe didn't adopt paper money until the 17th century. For over 1,000 years after China had moved on, Europe was still doing everything in coins. The first mechanized mint in the Western world was established in France in 1553, using a screw press powered by horses. Before that, every single coin in circulation had been struck by hand, a human holding a die and striking it with a hammer. Each one slightly different, each one a small act of manual labor. The modern coin press, capable of stamping 700 coins per minute with sub-millimetre precision, arrived in the 19th century with the Industrial Revolution. But the fundamental process, take a metal blank, apply enormous pressure with a designed die, create a standardized object of guaranteed value, has not changed in 2,600 years. The machines are faster. The principle is step 1, the metal. Modern coins are not solid gold or silver. They haven't been for most of a century. Today's coins are engineered alloys, precise mixtures of metals chosen for durability, cost, and the specific electrical and magnetic properties that vending machines and coin sorters use to identify them. The U.S. penny is 97.5% zinc with a thin copper coating. The U.S. quarter is a copper core clad with a nickel and copper outer layer. The U.K. pound coin is bimetallic, an outer ring of nickel brass and an inner disc of nickel-plated steel, specifically engineered to be almost impossible to counterfeit using standard equipment. Coin metal arrives at the mint as enormous coils of strip metal, typically between 50 and 100 centimeters wide and hundreds of meters. Step 2. Blanking, punching out the discs. The metal strip feeds into a blanking press. This machine punches circular discs, called blanks or planches, out of the strip at extremely high speed. The punches are precisely the diameter of the finished coin, and they stamp through the strip in rows, extracting as many blanks as possible from each meter of metal. What is left after blanking is a strip of metal full of circular holes, like a giant sheet of Swiss cheese. This leftover material, called the webbing, is collected, melted down, and recycled back into new coil. Nothing is wasted. The freshly punched blanks are rough-edged and slightly uneven. They go through an upsetting mill next, a machine that rolls each blank between 2 ridged surfaces, compressing the edge to create a slightly raised rim all the way around. This rim serves two purposes. It protects the coin's design from wear, and it helps the coin feed correctly through the stamping press in the next step. At this point, the blank is the right diameter and thickness. It has a rim, but it has no design, no lettering, no date. It is just a Step 3. The strike. The moment a blank becomes a coin. This is the heart of the entire process, and it happens so fast the human eye cannot follow it. The blank is fed into a coining press between two dies, one for the obverse, which is the head side, and one for the reverse, which is the tail side. A collar die surrounds the blank's edge. This is what creates the milled or reeded edge on coins like the US quarter or UK 50 pence. The press closes. For approximately 1/10 of a second, the blank is subjected to between 40 and 200 tons of pressure, depending on the coin's size and metal. In that fraction of a second, the metal flows into every microscopic detail of the die, every line of the portrait, every letter of every word, every fine detail of the design. Then the press opens. The finished coin is ejected. The dies themselves are masterworks of precision engineering. Each die is made from hardened steel, the design engraved or laser etched with tolerances finer than a human hair. A single die can strike around 300,000 coins before it wears out and must be replaced. At 700 coins per minute, that means each die lasts roughly 7 hours of continuous operation. The finished coins come out of the press already looking like coins, the design sharp, the edge clean, the surface bright. They are inspected by high-speed cameras that check every coin for defects, a cracked die, a misalignment. Let's go further inside what a real mint facility actually looks like, because it is unlike almost any other factory on Earth. Security at a mint is comparable to a prison or a military installation. Workers pass through multiple layers of security screening when they arrive and when they leave. All personal items are prohibited on the production floor. Workers in some areas must wear specially designed clothing with no pockets, specifically to prevent coin theft. Regular unannounced audits count every single blank, every finished coin, and account for every gram of metal that entered the building. The production floor itself is enormous, loud, and shockingly fast. The blanking presses, the upsetting mills, and the coining presses run in parallel production lines, dozens of machines operating simultaneously, each one a continuous blur of metal movement. The noise is industrial, mechanical, and constant. Finished coins move by conveyor into counting and bagging machines. They are counted to exact quantities, 50-cent rolls. 5 facts about coins that will change how you look at the change in your pocket. Fact 1. The United States loses approximately $300 million every year, not through theft or fraud, simply because people remove coins from circulation by storing them in jars, drawers, and forgotten pockets. An estimated 140 billion pennies are currently sitting idle in American households. The U.S. government must keep minting pennies to replace the ones that simply vanish into kitchen counters. The penny has cost more to produce than it is worth in face value every year since 2006, and yet it stays in production, partly because the zinc lobby and partly because retail pricing psychology depends on the 99-cent price point. Fact 2. Proof coins, the highly polished collector coins sold by mints directly to the public, are struck not once but twice by specially polished dies at lower speed and higher pressure than circulation coins. The result is a coin with mirror-like fields and frosted raised design elements so sharp they can draw blood if handled carelessly. A proof coin of the same denomination as a circulation coin can sell for hundreds or thousands of times its face value. Fact 3. Every coin in the world contains a secret security feature invisible to the naked eye. Modern coins include micro-engraved details, tiny text, patterns, and laser-etched markings visible only under magnification, specifically designed to make counterfeiting using even professional equipment detectable. The UK £2 coin contains a hidden latent image that shows the number 2 when viewed from one angle and the pound symbol from another, produced by microscopically different surface angles on what appears to be a flat field. Fact 4. The expression "not worth a red cent" refers directly to the copper coating on early American cents. The copper-colored penny was a relatively low-status coin as opposed to silver and gold coins, and calling something not worth a red cent was a pointed insult. The phrase is still in use today, even though pennies haven't been solid copper since 1982. Fact 5. Space coins are real. The Royal Canadian Mint has produced coins embedded with meteorite fragments, actual verified pieces of extraterrestrial rock, sold as legal tender collector coins. The Perth Mint has produced coins containing pieces of the moon, verified by NASA. These are genuine legal currency of their issuing countries. They have a face value, and they contain material from another world. A $20 coin with moon rock in it is technically valid for purchasing a cup of coffee. A small disc of metal with a picture pressed into both sides, the same basic object, the same basic idea that has run human commerce for 2,600 years. That was once struck by a person with a hammer in a Roman workshop is now stamped by a machine at 700 per minute in a building with no windows and no pockets allowed. The coin has outlasted every empire that minted it. It has outlasted gold. It has outlasted silver. It has survived paper money, credit cards, and digital payments. And right now, in the bottom of your bag or the back of your sofa, there are probably 3 or 4 of them, the most durable, most traveled, most continuously useful objects you own, ignored completely. Every object has a file. Every material has a story. We're